So operations with rational numbers in decimal form. So if you recall, we're going to combine our rules from integers and decimals. So let's start with addition and subtraction. For integers, if you recall, you probably worked with either integer chips, positives and negatives making zeros, and or you might have used a number line to help you. We'll go through both of those again. For decimals, adding and subtracting, you want to ensure that all of your place values are lined up, and you might want to fill in zeros where needed. So let's take a look at this first example. -4.7 minus 8.91. So as an estimate, we'll probably think of just what are the closest integers. So perhaps we're looking at -5 minus 9, and this kind of a question can be confusing to a lot of people, but remember, subtracting 9 is the same as adding the opposite, so -5 plus -9, and that reminds us that we're looking at -14. So that's what we're looking at as an estimate. If we're looking at doing this with chips, then, for example, we're going to say, hey, I've got -4 and decimal 7, so I'm just going to do kind of a little negative. So I've got -4 and something negatives, and then I'm going to add to that pile -8, 2, 3, 4, 5, 6, 7, 8 more negatives, and decimal 9, 1, that's that little bit. So you can see we can't make any zeros because we need a positive and a negative to make a zero. So all we're doing is we're accumulating more negatives. So that goes back to say why it is that we're adding. If we're looking at our number line, we're going to see the same thing. So we start at 0 and we go back to -4.7. So that's where -4.7 is on our number line. And then we continue going down -8.91. And so it's constantly going in the same direction. And so what are we looking at then is what is that total amount then? So what is that total amount from one end to the other end? And so that tells us that we need to add these values. Even though it says subtract, we're actually adding them. And this is where, if it's helpful for you, you want to add in something in hundredths place, you can do that as well. So then, even though it says subtract, actually you're going to think add. Okay, and everything here, the estimate, the integer chips, and the number line all point to us adding these values. So then we've got 0 and 1, so that's 100, 7 tenths and 9 tenths make 16th tenths, or 1 whole and 6 tenths, and then 4 and 8 plus that 1 is 13. But because we've got negatives and negatives, even more negatives, our answer is -13.61. If we take a look at another question, 2.45 minus 9.1, so our estimate then might be 2 minus 9, or for some people it might be 2 plus -9, in which case that would be -7. So we're looking for something around -7. If we're trying to think about this in terms of chips, so I've got positive 2.45, so we've got positive 2 and a little bit more positive, and then I'm going to add to that -9, 2, 3, 4, 5, 6, 7, 8, 9, and a little bit more, 9.1 negatives. So in this particular case, you could see that we can make how many zeros? Well, I've got way more negatives, but I've got 2.45 positives, so that's how many how many zeros we can make. So there's 1 0, there's another 0, and then if I take 0.45 positives and 0.45 negatives, that's another 0. So we can make 2.45 zeros, and then whatever is left is how many negatives, and that's our answer. Then if we're looking at that in terms of the number line, then we start at, again, 0, and we go up 2.45. So this portion is 2.45. And then from here, rather than continuing to the right, we're now going negative. So we're subtracting 9.1. So this whole portion then is 9.1. So looking at the number line, what do we have? We can see this little portion right here is 2.45. This whole stretch is 9.1. So then what is this portion in the middle then? And in order to find that, you can see again, what are we looking at is doing subtraction. So even though it says 2.45 minus 9.1, what are we doing instead is we're looking at 9.1 and we're subtracting 2.45. And right here, again, we want to add in a 0 to hold that spot. And so we think subtraction. Okay. And so 0 minus 5, we need to borrow from that 1. And so then that's 10 minus 5, which is 5. Again, we're borrowing or regrouping. 10 minus 4 is a 6. 8 minus 2 is 6. And because we know we've got way more negatives, we can see that with the chips. And we can also see that we end up in the negatives here. So we know that our answer is negative 6.65. We check that with our estimate of negative 7. And that seems to suggests that we're on the right track right there because we're pretty close to negative 7. So if you recall with multiplying integers, 2 negatives will make a positive. So if you have 1 positive, 1 negative, well, that's not 2 negatives. So therefore, positive times a negative will be negative. For decimals, easiest thing to do is to multiply as if the decimals aren't there. So in my example, you would be thinking to yourself 432 times 35. There's no need to line up the decimals when we're multiplying. We'll place the decimal after the fact. So if we were to line these up as 432 times 35, we already know that negative times negative, so we've got 2 negatives. Our answer is going to be positive. So I'll keep that in mind. Perhaps I'll even write the positive down. So looking at this, forgetting about those decimals, 5 times 2 is 10. Carry the 1. 5 times 3 is 15. Add the 1 is 16. Plus 1, that's 21. And then because now I'm looking at 35 or 30, so because it's 30 times 2, I'm going to just throw that 0 in there. So now I can just think of it as 3 times 2, which is 6. 3 times 3 is 9, and 3 times 4 is 12. So I add everything together. And so 432 times 35 would be 15,120. If I was to do an estimate, so even if I forget about the rule for decimals and where does the decimal go, even as an estimate, 4 decimal something times 3 decimal something, what would make sense in terms of placing the decimal? Well, I think everybody would agree that it would make sense to place the decimal at 15. So that confirms our rule. Because I have 2 decimal places here in the first factor, 1 decimal place here, then the total is going to be 3 places in my product. So we can count 1, 2, 3 places. And again, we already know that it's positive because it's two negatives, negative times negative. So then that would be 15.120, or just 12, because we don't have to include the zeros on the right. Good. So with division, integers, we should know that it's the same rules for dividing as it is for multiplying. That is to say that two negatives will make a positive, or one positive and one negative will be a negative. For decimals, what we want to do is multiply both the dividend and the divisor by the same number to make the divisor into a whole number, because most of us know our 2 times tables, our 3 times tables, our 4 times tables, but our 2/10 times tables, or 0.2 times tables, or 200th times tables, that just complicates things. So it's a lot easier to divide by a whole number. We don't care about whether the dividend has a decimal, because we can easily adjust that right here by moving the decimal from the dividend up into the same place in the quotient. Even though you're multiplying the dividend and the divisor by a number, the quotient will still stay the same. So we'll go through some examples with that as well, just to take note, and I'll mention them as well. So add zeros to the dividend if needed. And how do you know when to continue and when to stop that long division? Well, you want to continue either for one of 3 reasons: until the decimal terminates, then of course you're naturally done; until the decimal starts repeating, which means that you'll be otherwise doing this forever; or if the question asks you to round, then you want to give one more place than the question asks, so that you have something to round with. So for example, if it asks you to round to the nearest tenth, well, you need to know what value is in the hundredths place, right? So if you think about it, if I said round to the nearest tenth and all you have is 0.3 and you stopped, well, there's no rounding involved. But if you continued your dividing, and I'm not showing you what I'm dividing to get this, but if you kept on dividing and you end up with 0.34, oh, okay, well then to the nearest tenth, your answer will be 0.3. Does not matter what's going to be in the thousands or the 10,000th place. You're only looking at the place value immediately to the right of that. So let's just talk about this first portion for a moment. Okay, so let's take a look here. If we take something as simple as 6 divided by 3, well, obviously our answer is 2. If I was to multiply remember this is your dividend, the number that you're dividing into, divided by your divisor, and it equals the quotient. So if I was to multiply the dividend and the divisor by the same number, let's say we multiply them both by 10. My new expression would be 60 divided by 30. Notice the quotient is still 2. If instead I multiplied them both by 100, my new expression would be 600 divided by 300. The quotient is still 2. What happens if I multiply them both by, well, let's say 3? Well, then I would have 18 divided by 9, and the quotient is still 2. So, provided that I multiply both the dividend and the divisor by the same number, the quotient will still stay the same. So that means that if I have a question such as, let's change color here. So for example, if I have then 6.38 divided by 0.4, well, I know my 4 times tables, I don't know my 4/10 times tables, but if I multiply both the dividend and the divisor by 10, an equivalent expression will be 63.8 divided by 4. And I know that when I find the answer to that, the answer will be exactly the same as 6.38 divided by 4/10. No adjustments necessary. Okay, well then let's put that into long division. So the divisor goes on the outside, the dividend goes inside. So we've got 63.8, and I'm going to add a couple of zeros just to make sure that I've got enough. The decimal goes directly on top, and then we can go ahead and just start dividing. So 6 goes into, oh, I should throw in a negative, shouldn't I? So let's make it divided by -0.4, meaning it's going to be divided by -4, but that's not really going to make a difference. I've got a positive divided by negative. We'll just know that our answer, our quotient, will be negative as well. So 4 goes into 6 once. 1 times 4 is 4. Don't even worry about the negatives at this point. It's just going to complicate things if you do. 6 minus 4 then is 2. Carry down the 3. I'll draw an arrow to show that. And then 4 into 23 goes 5 times. 5 times 4 is 20. And then we subtract again. Answer is 3. I'll bring down the 8. 4 into 38 goes 9 times. 9 times 4 is 36. And subtract. And that is 2. Whoops. And I'll bring down a 0, and 4 goes into 20 5 times, and we know at that point there's 0 remainder, so I've run into this situation right there. How do I know how many zeros to keep adding? Well, I'm going to continue until the decimal terminates. So it terminates right there, so we know that 6.38 divided by -4/10 will be -15.95. Okay. Excellent. What happens, let's just do one more example here. So if I have, let's go with 0.38 divided by 0.003. So again, I know my 3 times tables. Oh, let's throw in some negatives, sorry. We're talking about rational numbers. Both of those are rational numbers, but it makes it more interesting with negative. So negative divided by negative, well, you guys already know that that's going to be positive, so no surprises there. So looking at this, we want to divide by 3 as opposed to dividing by 3/1000. So what would be an equivalent question? I don't care about the dividend, I care about the divisor. What am I dividing by? So I'm going to multiply that by 1000 to move that over 3 places. So that means that this has to move over 3 places as well. So the equivalent question will be -380 divided by -3. And so whatever the answer is to that will be the answer to -3800 divided by -3000. So if we set that up then, 3 into 380, and so I'll just start that. 3 into 3 goes once, no problems there. 3 into 8 goes twice. 2 times 3 is 6, and subtract, and that's 2. Bring down the 0, and 3 into 20 goes 6 times. 6 times 3 is 18. Subtract, and that's 2. There's no zeros here, so I need to add in a decimal and a couple of zeros. As soon as I add in the decimal, I need to put the decimal into the quotient as well. So now I have a 0 to bring down. 3 into 20 goes 6 times, and 6 times 3 is 18. So we can already see that the same thing's going to happen. I'm going to end up with 20 and 18 and 20 and 18. So we can stop right there, and that's my second example of how do I know when to stop? Well, when I've determined that it's continuing. And so we can put the bar across the 6 to indicate that that 6 is repeating. I hope it's, if you forget, remember that you cannot put, even though the 6 in the ones place is going to be the same 6 that's repeating, because it's in the ones place, I cannot write this. That would be incorrect. We don't put a bar on any of our whole values. So you have to rewrite the 6 as the decimal place and indicate that that is repeating. Okay? Well done. Of course, with any of these questions right now, as you're practicing, you can certainly check your work using your calculator. Let's review order of operations. Most of you know it as BEDMAS or PEMDAS, the difference being B for brackets or P for parentheses, remembering that brackets refer to the operations inside the brackets, and any operations, if there are multiple operations inside the brackets, those will also follow BEDMAS. E is of course for exponents. D and the M is division or multiplication from left to right, whichever comes first, and addition or subtraction, whichever comes first from left to right. So notation, I can be very, very particular about notation. So what we're looking for, what I will be looking for, is proper notation along here, along the left. That's nice and clean. I won't know whether or not you've used a calculator, but I will be looking to the right, since you won't have a calculator, to see how you did all of your operations. So as we're looking through this, what I often like to do is suggest that you underline what our first operation is going to be. So we can see the brackets right here, and we see brackets right here, but these rounded brackets are actually referring to, not referring to, but are keeping that negative with the 1.3. So these brackets don't have to do with the brackets in BEDMAS. The square brackets do, however. And so we can see inside those square brackets we have addition, we also have multiplication. So the multiplication is going to come first. So off to the side, you're going to start with 8.5 times 1.3 or times negative 1.3. So just hit pause right now and work through that multiplication then. So with the multiplication, we can see that 85 times 13 would be 1,105, because if we look at an estimate, 8 times 1 is going to be 8, so the closest thing to that would make sense that then it's 11. Our rule confirms that when we look at, there's one place here, a second place here, so we're looking at 2 places then in front of the decimal there. So positive times negative is negative. So when we rewrite this as the next step, I want to write everything in order and just replacing the operation we've done with the simplified form. So our new and improved question, 10.1 minus negative 3.2 plus negative 11.05. So next operation then, so we still have that bracket. So at this point we want to add negative 3.2 plus negative 11.05. So again, hit pause and please complete that operation of negative 3.2 plus negative 11.05. And we can see that since it's negative and a negative, perhaps you've drawn out some chips, and you can see, hey, I've got negative 3 and a little bit for my 0.2, and then I'm adding to it 11 more negatives, and I'm not going to do all of the 11, but you can see we're not going to be able to make any zeros, so it's just more and more negative, so we're just adding and finding that total. So again, looking at the notation, so we're going to copy everything down in order, 10.1 minus, and when we get to the operation, we're going to leave the simplified form, so minus, I'll probably use a round bracket right now, negative 14.25. And then at this point, minus and negative, hopefully you guys recall this, that it is the same as adding a positive, and so it's just 10.1 plus 14.25, and so some of you are able to do mental math, others of you are going to line that up, and that would be fine as well, but we're looking then at, oops, so our answer then is 24.35.